Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Muhammad Haziq bin Muhammad Hashim, together with my group mates, Muhammad Shamsul Hasrim bin Cik Hashim and also Muhammad Rosdi bin Osman. We are from Group 5. Now, we are conduct the case study for subject BTV 3453 Energy Audit. Our lecturer is Associate Professor Dr. Cikgu Muhammad Faizal bin Cikgu Yahya. Okay, now for the background of case study. Okay, the building location that are selected in the case study is the residential college 4, RC4. So the RC4 itself is consists of two condominium buildings. Each has 8 floors and also 2 blocks. Okay, each floors contains 8 houses. Each house has 4 rooms and 2 bedrooms, and it can accommodate up to 8 students. Okay, the RC4 is reserved to male students only and is provided to all first year students. But if there any available house unit, it will be offered to the second year students and above. All houses in RC4 are equipped with Wi-Fi coverage. Okay, now what you can see is the inside the house. The figure 2 is the kitchen, and also the figure 3 is the hallway for the house. The hallway picture is taken from the front door view. Okay, now for the inside of the house and the building, the figure 4 shows the living room, and also the figure 5 is the floor corridor. Okay, now for the floor plan for each RC4 house unit. As you can see, there is a veranda, 1 living room, 2 toilets, and 4 rooms. Okay, there are 6 objectives for this case study. Number 1 is to assess the recent pattern of energy consumption in different cost centers of operation. Number 2 is to find the relationships between energy input and usage output. Number 3 is to identify the potential electrical energy conservation. Number 4 is to outline the wastage in major areas. Number 5 is to determine the energy saving on potential targets. And also number 6 is to implement the energy conservation measures. Okay, now for the purpose of energy audit conducting for the case study is because the energy audit itself is a process to evaluate where a building or plant uses the energy. Okay, in this project, the subject of research is residential college 4, particularly to determine the usage of energy by the residential students based on the type of energy used and its duration. This auditing process can identify opportunities to reduce the consumption. Okay, now for the scope of energy audit in this case study. Okay, the energy auditing process can be achieved under several scopes. There are 3 scopes that are available. One is the complexity, number 2 is the economic evaluation and issues levels, and number 3 is the calculation involved level. Okay, for the complexity, to conduct the lighting audit, the basic lighting information is required, such as the number of lights utilized, the locations, and also the operation time. Okay, for the economic evaluation and issues level, okay, the evaluation measures need to be taken into consideration, but due to the COVID-19 pandemic situations, the on-site data could not be measured. Only the number of lights, lamps, and type of lamps are only the real data. Okay, and for the calculation involved levels, the calculations such as the lux, operating time, kilowatt hour per day in each house, and also the kilowatt hour per day for buildings will be used in this project. Okay, now for the audit levels. there are three audit levels. Number one is the walkthrough audit, number two is the standard audit, and number three is the computer simulation. Okay, for the walkthrough audit itself, it can be identified as the visual inspection through the energy using system on a respective building. And for level 2, the standard audit, its purpose is to quantify the energy usage and losses. This level gives more detailed analysis of equipment, systems, and also the operational characteristics. And for the level 3, the computer simulations, it is accomplished through the use of computer simulation software that give more details of energy usage and pattern, and also it involves the auditor who responsible in developing the computer simulation of building system to calculate how much the energy consumptions in respective buildings. Okay, now what you can see is the table for the recommended average illuminance level, DMS 1525 2014. Okay, this MS 1525 2014 is a Malaysian standard for energy efficiency and use of renewable energy code of practice. This standard is comply with the MS ISO 8995 for the minimum safety standard for interior lighting. So I will pass to the next presenter.
For the methodology, all of the data was obtained during the walkthrough audit, including the layout design, the power bill and technical information for electrical equipment such as air conditioning and lighting system. By following standard audit, there are 2 types on-site measurement was performed, which is room data survey, lighting measurement in each of the room in KK4, floor corridor, administrative office and student lounge. The energy equipment that used to measure all parameters was lug meter, temperature humidity meter and indoor air quality analyzer. Post-audit were followed to determine of energy consumption index, including building energy index, air conditioning index, lighting energy index. This index representing the actual energy consumption of the building by on-site measurement. Finally, energy and cost saving were calculated to recommend preventive action of excessive energy consumption or ACM. The audit areas of KK4 building and operation data are summarized in the table below. Next, electrical component in KK4 building. The electrical components used in KK4 building are lighting system, air conditioning and fan system. For lighting system, the whole building are installed with fluorescent lamp as the main lighting system, while only several spaces are using LED lamp like office and student lounge. Then air conditioning and fan system. Most of the electrical fitting in KK4 in every house are fans. The use of ceiling fan cover every student room. The ceiling fan also covered in living room in the student house. Air conditioning system in KK4 building is only installed in the residential college office and international student room located in Block A.
From the table of energy consumption and the cost in KK4, we can see that the lighting contributes to the highest in energy consumption, which is 34.38%. From the data, for the total energy usage, it costs Rm 9,633 ringgit. The data also show that the air conditioning and the ceiling fan consume high energy usage, which is 30.98% and 34.3% accordingly. The cost that need to be paid for the air conditioning and ceiling fan is Rm 8,682 ringgit and Rm 6,820 ringgit. The total energy consumption for the KK4 is about 86,749 ringgit, 49 kilowatt hour, and the cost of the bills is about Rm 28,084 ringgit per day. Student residential environment can usually be attributed to the high use of the light and fans. Prolonged use of lighting can lead to a waste of energy. There are some practice of the main cause that may lead to the energy wastage in KK4. The first one is the lighting system. When it comes to the lighting, many individuals make the error of the adjusting of the brightness of the whole room with lighting, which can result in expensive power costs. The building's orientation is not capable to exploit natural day lighting. Therefore, the artificial lighting is the main option instead. From the observation, lighting that are not in use sometimes are being switched on and lead to the energy expenditure. The second one is the usage of the air conditioning system and the ceiling fan. The energy usage of the air conditioning is much higher than the ceiling fan. Even though the amount of the air conditioning does not exceed more than hundreds, there are total of the 64 units of the air conditioning used just for this building. Turn out about 70,000 watts of the power is required to cool the space just for one day. This consumes high amount of energy and increase the cost of electricity. More power consumption is required if the student setting the temperature to the maximum of the maximum coolness, which is 60 degrees Celsius. The emphasis of the energy management system is on an efficient and long-term energy management approach. It can also assist in the lowering energy costs and efficiently managing the energy use. Basic energy knowledge has been distributed to the personnel, but no systematic energy management system has been built at the KK4. The building's energy usage pattern is deemed inefficient for the following reason. The first one is there is no systematic energy management system that outline the energy policy, the objective, action plan, and also the comprehensive energy monitoring. Secondly, lack in the operation and also the maintenance of the inefficient electricity components. Last one, there is no previous energy audit program was executed. Therefore, nobody cared about the importance of the energy saving measure, and the findings of the solution. The energy management metric show that the present state of the KK4 building's energy management system. Obviously, there is no formal energy policy in this building, but there are certain unspoken norms. Besides that, there is no corporate commitment and formal involvement in the energy management. For marketing parts, informal contacts are used to promote the energy efficiency. Only low-cost measures were taken at this moment. Thus, SAMS is proposed to improve the current situation into the specific target in the energy matrix. From the table, there is a comparison of the data measured with the standard MS 1525-2014. The student resident, student lounge, office, and toilet show that the result of the overlit, but the floor corridor is underlit.
Next is energy conservation measure, ECM. In regard to achieve energy saving goal in the building, 3 ECM including low cost and medium cost were considered. First ECM is Sustainable Energy Management System, which is SAMS. To save energy in the faculty, a sustainable energy management system framework might be adopted. In general, there are a variety of ways to save energy, such as turning off light, air conditioning, and other appliances when they are not in use. The air conditioner is being reset. It is also highly useful to save energy by setting the thermostat to a comfortable level between 33 degrees Celsius and 36 degrees Celsius. SAMS was projected to save roughly 58% of energy. Second ECM is retrofitting of LED lighting. Lighting control is one of the most prevalent energy saving techniques since it is one of the simple methods to produce significant energy saving for every minimal expenditure. As a result, this research proposed LED light to upgrade light at the KK4 building to conserve energy. LED are also long-lasting compared to fluorescent lighting, lowering maintaining costs. As a result, by completely implementing LED lighting, it is possible to cut energy consumption usage. Lastly, air conditioning and ceiling fans. Even the use of ceiling fan more than air conditioning, but the energy consumption rate for air conditioning is very high. Therefore, the regular maintenance such as changing air filter, especially during high operation time, a clean filter can prevent dust and dirt from enter the system to make sure the air conditioning does not require much energy to operate.
The table shown that the energy saved after the implementation of the ECM in KK4 per day. The replacement of the lighting, the energy consumption produced after the ECM is 650 kilowatt hour. Ceiling fan is 528 kilowatt hour and the air conditioning maintenance is 320.83 kilowatt hour. The table shown the comparison of the energy consumption before and after implementing the ECM in year. From the data, it can be seen that the energy consumption before implementing ECM is 772,722 kilowatt hour, which cost Rm 249,589 ringgit, while after implementing the ECM, the consumption drops to 449,669 kilowatt hour, which cost Rm 145,236 ringgit. The annual energy saving after implementing the ECM is 323,073 kilowatt hour, and the percentage of the energy saving is about 58%. By implementing the ECM, the cost can be saved to Rm 104,352 ringgit. For the investment, there are two investments that should be made, which is the first one is the replacing the new bulb, and the second one is the maintenance of the air conditioning. For the replacing the new bulb, the T5 LED bulb is used with price is Rm 20 ringgit 80 cent per unit. Therefore, the total investment for the new lamp is Rm 40,268. The investment of the air conditioning, the regular maintenance should be down, and the cost of the maintenance is calculate is about Rm 76,736 ringgit. Then the total investment for the two components is about Rm 170,004 ringgit. The payback period for the investment is 30 months, and the profit can be obtained after 2 years.
In conclusion, energy audit is the first stage in understanding how energy is utilized by building and how to conserve energy to discover possibilities for energy conservation in KK4 building. By implementing energy conservation measure, the annual energy consumption can be saved up to 320,073 kilowatt hour per year, and the annual cost saving is 104,352 ringgit. If T5 LED light can be and inverter air conditioner are used to replace existing component, and investment of Rm 117,004 ringgit is required. Within a year, the payback period can amortize. Implementing ACM in KK4 make it possible to reduce the total energy consumption from 249,589.21 kWh per year to 145,236.63 kWh per year for the three components. By implementing ACM, it can save energy consumption as well as reduce the cost of paying bill. Last but not least, student awareness and initiative about the importance of saving energy is also important in reducing unnecessary energy consumption and sustaining long-term energy efficiency in KK4. That's all from us. Thank you.